Let's talk about some trig equations that aren't necessarily cut and dried answers from our memory of trig functions. So I'm going to call this trig equations part 2. We had one part that had exact answers. This one doesn't necessarily have exact answers. It may, but there are just a little bit more involved. So remember what we do. We try to figure out what kind of equation. Is it linear or quadratic or what? There are a lot more than just linear or quadratic, but those are basically what we focus on. And then I want to know what is the reference angle. And then I need to deal with where are the answers. So what's the domain? What's the possible place for answers? Like, are we going around the circle one time? Or are we going from 0 to pi? Or what are we going to do? And also, are they in radians or in degrees? So that's kind of important too, okay? So here's what we're going to do. I've got a few examples. Just try to toss them out here and we'll work them and see what we can do. First one I've got is this. The sine squared of x over 2 minus 2 equals 0. That is quadratic, and it can be solved by quadratic formula, factoring, trying to take the square root of both sides. There are a lot of techniques that you should know from algebra. I'm going to do an algebra technique that we're probably fairly comfortable with, and I've got to do something with x. I'm going to say that x is in the region from 0 to 360 degrees. So there's my place for my answers. All right. So sine squared of this. First thing that we need to notice, and this doesn't have to be done first, but it has to be done, we've got x over 2. So if x is between 0 and 360, then x over 2 is between 0 over 2 and 360 over 2. 360 over 2. So actually our x over 2 value is going to be between 0 and 180. Okay? So that's where our region actually is going to be when we solve for x over 2. All right, so sine squared of our angle x over 2, I'm going to add 2 to both sides, so equals 2. So the sine of x over 2, took the square root of both sides, is equal to plus or minus the square root of 2. Now this one's kind of interesting because we get the sine of something is equal to the square root of 2 or minus the square root of 2. Well, if you do that, you might try it on your calculator if you can't think of the answer, but the square root of 2 is more than 1. The example or the calculator would give you something like 1.414. Sine function is never 1.414. It's locked between 0 and 1. So this has no solution. No solution. Okay? So no answer to that problem. Let's try another example, one that hopefully does have an answer. This one's got 2 times the cosine of 2x equals negative 1. And again, I'm going to have x between 0 degrees and 360 degrees. So if we're working with 2x, let me do the same thing I did last time. 2x, if x is between 0 and 360, then 2x is between 2 times 0 and 2 times 360. So we have to go all the way from 0 in our answers to 720 degrees. All right? Way to go. Okay, so let's try to solve this. This one's linear. And so it's a little easier than this one in some respects. let's just divide both sides by 2. So we get the cosine of 2x is equal to minus a half. Now, we've got 2x. That's fine. We'll get x eventually. But where is the cosine equal to minus a half? Well, first of all, let's deal with the reference angle. Where's the cosine equal to plus a half? 1/2 reference angle is 60 degrees. So that's from your memory of exact values of cosines and sines and so forth. So our reference angle is 60 degrees. 60 degrees, but this has got to be negative. So we've got to have 60-degree angles in what quadrants? The cosine is negative in quadrant 2 and in quadrant 3. So we've got to go 60 degrees in quadrant 2, quadrant 3, around the circle twice. So 2x is equal to these options. First one in quadrant 2, a 60-degree reference angle, 120. In quadrant 3, 180 plus 60 is 240. Okay, we've got to go around the circle one more time. So add 360 to this. 360 to this gives us 480. Add 360 to this, you get 600. So we've got 4 answers. Divide each by 2 to get x. So x is equal to, let me go ahead and bracket these off so it looks like a bunch of answers. So if I divide each one by 2, I get 60. I get 120. I get 240. And I get 300. So those are the actual answers, but we went ahead and solved for 2x and then solved for x. So that's the way that you would work one out. Now I've got another one that's kind of similar. It's got a little different answer. This one has the sine of theta over 2 is equal to minus the square root of 2 over 2. And I want theta to be between 0 and pi, 2 pi. Okay? So let's let theta be between 0 and 2 pi. So we're in radians now. We've got to answer our question in radians. The process works the same way though. This one's already solved for sine, so we've got to get the angle out. Well look, theta over 2 has got to be between 0 over 2 and 2 pi over 2, which is 0 and pi. 0 and pi. So our answers for theta over 2 are going to be between 0 and pi. Now, what's the reference angle? I ignore the plus and minus, so where's the sine equal to square root of 2 over 2? That is a pi over 4 reference angle. But we've got to have where the sine is negative. Okay? So we've got to have the sine value is negative. That would be in quadrant 3 or in quadrant 4. We don't have quadrant 3 and quadrant 4, so this one has no solution